Now let's say that we want to extend our experiment and now we want to take measurements for two additional resistors. We want to take an additional measurement for 20 ohms and 30 ohms. So let's first create our values. Our voltage will stay the same, but now we will have new resistances and new currents. So I'm going to change this to R1 and I'm going to rename our current to I1 as well. Now we are going to add R2 equals to 20, R3 equals to 30, and we're going to calculate three new currents. So I2 equals U divided by R2 and I3 equals U divided by R3. Our plot still works just the same. And now we need to add these two new currents for the two new resistances to our graph. There are two ways to do this. The first is to keep adding more and more data to be plotted in your plot function. So here we can additionally say U, I2, U, I3. And if we run this, we get all of the data here. Each of the graphs, as you can see, gets a different color. We can control these colors, but it's very messy to do this in a one single plot function. You have to keep writing on the same row for that same plot function that has three graphs. And this is not productive, this is not pretty, it's just messy. So, how do we fix this? The approach to fixing this is very easy. It is to separate each of these graphs in separate plot functions. So we can say plot of yi2 and plot of yi3. Now let's delete them from here and let's run the code and see what will happen. And as you can see, we still didn't get the result that we expected. We actually got only one single graph and the rest are non-existent. This is because they got overwritten, so each of these plot functions overrode the previous one. To fix this, we need to use the hold function. So we need to say hold on. This means that after we create our first plot, that plot will be held on to and any additional plot will be plotted along with that first plot. If I run the code now again, we get all of our plots on the same graph exactly as we wanted them. This way, we can also easily customize each of these plots. So we can say that we want our second plot to have a green color. We want the line width to be again 2. We want the line style to be, let's say, a dashed line, and we want. So I'm just going to fast forward because we already know this. So I'm just going to fast forward with all of the stylings. So alright, and let's run the code now. And you can see that all of our graphs have their individual stylings. Now, one last thing that we need to do here is to fix our limits, even that they seem to be okay, and they are. There are occasions in which this may not be true, so we need to now start working with the minimum and maximum values of all of our current vectors. Here currently I'm working with the first vector, which has the biggest values, but if we switch this to I3 and I rerun it, you can clearly see that some of these vectors get lost in our on the y-axis. As you can see, we are only able to fully see our third vector of values, but our first and second are just not visible in their entirety. The second vector continues somewhere to here, and the third continues even further down the plot. To fix this, we can simply concatenate all of these three vectors and find the minimum value across all three vectors and the maximum value across all three vectors. So we can say I1, I2, I3 like this, and we can do the same thing for all of our min-max functions here. If we rerun it, it's now once again working exactly as it should, but now no matter what values we have in any of these vectors, the minimum and the maximum value will be found across all of these vectors, and the y limits will always be the way that they should be. Now, instead of creating 4 vectors for each of these commands every time we use it, we can extract them. We can say oy values equals to that vector, and we can simply substitute oy values everywhere where we need to use them, like that. And there we have it, it's still working.